Ladies and gentlemen, I introduce report formation of a method for estimating the error of determining the coordinates of the source of a sound anomaly. This report is the result of scientific research multidisciplinary teams from Petromohyla Black Sea National University. Zhan Byelozyorov, Serhii, Maltsev, Maksym, Skoroid, and me, head of project, Alexandr Trunov. The strategy of offensive and defensive action demonstrates the success of the use of unmanned aerial vehicles and anti-tank robot systems. These results show that the paradigm of automation and implementation computer integrated technology, aims of which to maximize the preservation of personal changes the old work paradigm of 20th century. The main idea of which was success determined by dominate by the number of personnel and tank with artillery. The modern works of the last decade reveal advantages of uses drone for competitive video and audio reconnaissance, which complemented each other in information and allowed to enter this information in the electronic fire map of the department. However, despite the advantages of such implementation of computer integrated technology, the complication of effective use of methodological measurement scheme used in the lake of binding of coordinates of the carrier and device for determining coordinates of the source sound anomaly relatively to one basic coordinate system. In addition of its unreasonably assumed that the error of the coordinates of the center of gravity of the drone as determined by GPS is zero, and also it is relative orientation does not contribute to the magnitude of the error. In the work of scientists from Hetman Petro Sagaidachny, National Army Academy, Lviv Polytechnic, Kyiv Polytechnic National Universities, and Petromohyla Black Sea National University, and our scientists are shown the necessity and the reality of application of the both drone and mobile robots. As it's shown in work by academic Palagin and colleagues, improvement of method and means of constructed dynamic scenarios in the work of navigation graphic information system based on principle of sound location is also based on the development elements of computerized system and require comprehensive accounting of all components that form the error of the devices as a whole. Thus, the search for cases of methodological and random errors is mobile monitoring system by drone and has emerged as an unsolved problem due to growing need for accurate assessment and application requirements. Thus, the availability of hardware which has been created recently will contribute to the formulation and solution of the problem, developing a perfect methodological scheme and method of correctly estimated maximum possible error. The aim of the work is improve the quality of computerized system of microphones for registration of sound anomaly by simulation according to components that form the error, evaluation of widths, and introduction of algorithm that reduce error. To achieve this goal, the following tasks were set. Set of tasks and conduct a simulation of random process that form a random component of error. Carry out a comparative analysis of estimates of maximum possible error of algorithm for symmetric and asymmetric echograms. To analyze the algorithm for recognizing and determining the time fixation of complex echograms. For numerical experiment was considered the model computerized system consisted from 4 microphones, each of which is located at the vertices of the equilateral pyramid with equilateral triangle at the base. The beginning of connected Cartesian coordinate system, the point O coincide with intersection of the bisectors of triangle base. Our hypothesis: the sound anomaly are point sources. Angle which change randomly by the normal low Gaussian density determined by equation 1. The microphones is point receiver. The range of change angle will be limited interval, was calculated from this range by expression equation 2. The distance from wavefront to the microphone will also be a random variable and will be equal to equation 3. The amplitude of the wave is inversely proportional to the square of the distance, equation 4. For scientifically based choice of equipment for experimentally studying propagation of sound anomaly wave, the nature of its attenuation and modeling the random position of point of origin of the source sound anomaly, it was proposed to use a simulation, a rotary platform on thrust bearings driven by stepper motor to change position, which is determine equation 1 to equation 4. The single phase excitation scheme stepper motor, model for numerical simulation built in MATLAB, is shown in slide 9. Formation of rectangular voltage drop pulse and our form of pulse, amplitude and time, length according to values specified in dialog box, make such a scheme convenient and to easily conduct experimental simulation based on Monte Carlo simulation. On the figure 2 shown some example formation input signal, step and dir. On the figure 3 shown as example reaction of random number angle as rotation of platform. On the figure 4 shown some our signal as oscillogram in different channels of this scheme. On the figure 6 shown some specially formed by input random signal, output form for angle position of platform. For the figure 8 shown some triangle output signal. This form of output signal from platform give possibility to propose this model of stepper model applied for our simulation. Those the error resulting from hypothesis of intensity constancy, case an error in determining the time according to the echograms can be determined by equation 5 in using method of recurrent approximation. Consider the case of monitoring and control by drone. The physical field wave intensity is scalar value and inhomogeneous. In this case, error of its measurement is determined not only static error and determined by our factor as equation 6. For numerical experiment was used some number of example echograms. Parameter for 4 example of used echograms shown in table 1 for symmetric sound anomaly echograms, for asymmetric sound anomaly echograms table 2, for composition of sound anomaly echograms table 3. For this different type of set of parameters and type of echograms was made numerical experiments. Result of this experiment shown on table 4. For different example echograms, for different distance between sound anomaly and microphone, shown maximum intensity error and absolute time error and relative coordinate error of this table 4. The reason of increasing general error is algorithm of determining the moment of time phase in echograms. We investigate 4 algorithms. As a result of investigation with 4 algorithms, to analyze the advantages and disadvantages on algorithm 4, we proposed algorithm number 5, which is generalized first 3 algorithms. Result of applying algorithm 5 and algorithm 4 for different distance between microphones shown in table 5 and table 6. Algorithm 5 is not accurate as algorithm 4. Algorithm 4 very accurate, but time for this realization is much more bigger than for algorithm 5. The task of simulation modeling and estimation of magnitude components of the maximum possible error that occurs then determining the coordinate of sound anomaly is set and carried out. Comparative analysis of simulation result shows that the distance between source and source anomaly and the relative position and distance between microphone of computerized systems significantly affects on the amount of static error. Those then increasing the relative distance from 41.66 to 82.33, the error decreased from 0.07 to 0.05, and then almost unchanged for case of symmetric echograms. The choice of algorithm does not significantly affect the estimation of static maximum possible error in determining of coordinate sound anomaly for symmetric echograms. However, for asymmetric echograms, the choice of algorithm significantly recognizes its value. The algorithm for determining the moment of time of the identical phase of the occurrence of the wavefront is determined by required accuracy or required calculation time. For critical accuracy, more preferable is method recurrent approximation algorithm. It's algorithm 4. And a critical time acquire algorithm 5. Thank you for your attention.